Trig equations. We'll be using the unit circle to find our solutions to these trig equations. So make sure you have a copy of the unit circle in front of you. We'll give all of our answers in radians, and we'll be using the entire circle. Our answers will fall between 0 and 2 pi, and we will usually have 2 answers for each of these equations. So to solve this, we want to get rid of cosine so that x is by itself. And the way you get rid of cosine is you apply the inverse cosine. So we do inverse cosine on the left, then those cancel, inverse cosine on the right. So if you remember the lesson about inverses, what we're trying to find is where on the circle does the cosine equal square root of 2 over 2. And we can look at the entire circle. So there are 2 places that happens. That happens when we are at pi over 4, and it happens again when we are at 7 pi over 4. Those are the 2 places where the cosine is square root of 2 over 2. Tangent theta plus 1 equals 0. So first let's get tangent theta by itself. Subtract 1 from both sides. Tangent theta equals negative 1. And then to get rid of the tangent, we do inverse tangent. And when you do inverse, you're saying where on the circle does the tangent equal negative 1? And that happens in 2 places. That happens at 3 pi over 4 and at 7 pi over 4. So those are our 2 solutions. 2 sine x minus the square root of 2 equals 0. So let's add square root of 2. 2 sine x equals square root of 2, and divide by 2. So sine x equals square root of 2 over 2. Now I want x by itself, so we do inverse sine on both sides. And so now we're looking to see where on the circle that sine equals positive square root of 2 over 2. That happens at pi over 4 and at 3 pi over 4. This one's more complicated. We have a cosine squared and a cosine and then a 2. And if you think about it, this is in the same form as 2x squared minus 5x plus 2. We're going to temporarily replace the cosine thetas with just an x to make it easier to work with. So what we've got here is something that can be factored. So if I multiply the first number times the last number, I have 4. Factors of 4 that I can use to get the negative 5 in the middle, negative 1 and negative 4. So 2x squared minus negative 1x minus 4x plus 2 equals 0. And then I group. Out of the first 2, I can take an x, leaving me with 2x minus 1. And then there's a minus. Out of the second 2, I can take out a 2, so dividing out a negative 2 leaves me with 2x minus 1. So then factored will be 2x minus 1, and then the outside values x minus 2. Now if you have trouble with factoring, that's not really part of this lesson. You can get on the internet and look up all kinds of practice for factoring. Now that it's factored, I'm going to put the cosine thetas back where the x's are. So 2 cosine theta minus 1 times cosine theta minus 2. Then we'll set each term equal to 0. 2 cosine theta minus 1 equals 0. Cosine theta minus 2 equals 0. Add 1. 2 cosine theta equals 1, and divide by 2. Cosine theta equals 1/2. On the other one, add 2. Cosine theta equals 2. Then I'm going to do inverse cosine on both sides. sine. And so I'm trying to find on the circle where the cosine is positive 1/2. And that happens at pi over 3 and at 5 pi over 3. Now on the other one, cosine theta equals 2. If I do inverse cosine on both sides, I'm looking for where the cosine is 2. Well, that never happens because cosine never goes above positive 1. It never goes below negative 1. So this one would be undefined. So the only answer that works is pi over 3 and 5 pi over 3.